Hello, a question for you. If your acceleration is negative, does it always mean that you are decelerating? Not necessarily so, yeah? So to understand this, you got to understand something called the sign convention. So suppose you are moving rightward at the speed of 2 meters per second. So if we are using the rightward is positive sign convention, then this rightward velocity is represented with the number positive 2 meters per second. If you are moving leftward in the opposite direction at the speed of 3 meters per second, then using the rightward is positive sign convention, this leftward velocity must be represented by negative 3 meters per second. Now, between these two velocities, which is the higher speed? Definitely this one, yeah? This is the higher speed. But what about the numbers representing these two velocities? Actually, this one is the larger number, isn't it? So do you notice that even though the number representing the velocity could be larger, the speed could be slower. So keep this in mind, yeah? Okay, let's look at this velocity time graph here. So we have an object whose velocity is changing from 0 to positive 5 to 0 to negative 5 and back to 0 again. So how would you describe the speed of the object during this part? Speeding up, right? And then it slows down. What about from here to here? It may look like something is decreasing, but be careful, huh? The object is speeding up. The velocity is getting more and more negative, so you're speeding up in the leftward direction. Likewise here, well, the object is actually slowing down. The velocity is changing from some very negative number back towards 0. So you are going leftward, but at a slower and slower speed. Get it? So now let's talk about the accelerations. So during this part, the acceleration is actually positive 1 meter per second square and you are speeding up. During this part, your acceleration is negative 1 meter per second square and you are slowing down. What about this part here? The acceleration is actually negative 1 meter per second square, but you're speeding up. Why is that so? Well, look at the numbers representing your velocities. It's changing from negative 1 to negative 2 to negative 3 to negative 4 to negative 5. So arithmetically speaking, your velocity, or at least the numbers representing your velocity, is decreasing at 1 meter per second per second. That's why the acceleration is represented by a negative number, even though you're speeding up. Similarly, during this part here, your acceleration is actually positive, even though you're slowing down. Because the numbers representing your velocity is changing from negative 5 to negative 4 to negative 3 to negative 2 to negative 1 to 0. Arithmetically speaking, the numbers representing your velocity is increasing at 1 meter per second every second. That's why the acceleration is represented by a positive number, positive 1 meter per second square. But you are slowing down. Basically, students have no problems when the velocity is positive. When the velocity is positive, a positive acceleration means speeding up, a negative acceleration means slowing down. Everybody has no problem with that. But when the velocity is negative, then some students get confused, yeah? Because when the velocity is negative, if the acceleration is negative, you're actually speeding up. But if your acceleration is positive, you're actually slowing down. Some students are very sharp and then they can see the pattern. They can make this conclusion. They'll say, so if the velocity and acceleration are of the same sign, then you're speeding up, right? Like here and like here. But if the velocity and the acceleration are opposite in signs, like here and like here, then you're slowing down. These are very smart students. Alright, ta-ta!